Dear students, welcome to the lecture series on the topic Engineering Graphics. Today we are going to discuss about orthographic projections of the points. I am Dr. IPS Ahuja, Professor, Department of Mechanical Engineering, Punjabi University, Patiala. So here we are required to evaluate the orthographic projections of a point which happens to lie into the fourth quadrant. So here we have got a spatial arrangement into which the horizontal plane, the vertical plane, the left hand side view profile plane and the right hand side view profile plane. So they are arranged to divide the space into four different quadrants over here. So this is the first quadrant, this is the location of the second quadrant, this is the location of the third quadrant, and this is the location of the fourth quadrant. So we know that whenever an object or a point, it is to be located into the fourth quadrant, so object will be lying below the horizontal plane and in front of the vertical plane. Now we know that whenever a point is located in any quadrant, so the front view, top view, left hand side view and the right hand side view orthographic projections, they are going to be obtained into the mutually perpendicular reference planes over here. So we need to carry out the rotation of these reference planes in such a way that we should be able to obtain all these orthographic projections into a single 2D plane over here. So let us observe where we are going to obtain the projections of a point D which will be located into the fourth quadrant at a distance of 35 millimeter below the horizontal plane and 25 millimeter in front of the vertical plane. Here we have located a point D at a distance of 35 millimeter below the horizontal plane and 25 millimeter in front of the vertical plane. So as the observer is going to look at this point D from the front view orientation, so we are going to obtain the front view projections, that is D dash, obtained onto the vertical plane below the XY reference line. And now when the observer is going to look at this object from the top, so the top view projections of this point, they will be obtained onto the horizontal plane which is lying in front of this vertical plane over here. And now this top view projection, that is point D, and this front view projection, that is point D dash, they are lying into the mutually perpendicular planes over here. This portion of the horizontal plane which is lying in front of the vertical plane, it has to be rotated into the clockwise direction, that is into the downward direction over here. So now we are going to witness the overlapping of this horizontal plane and this vertical plane available over here. So now depending upon the distances from the horizontal plane and the vertical plane, we will be able to obtain both of these front view projections and the top view projections over here below the XY reference line into the fourth quadrant. Now when the observer is going to look at this point D from the right hand side view orientation, now we observe that the right hand side view projection of this point D will be obtained on the left hand profile plane over here. This portion of the left profile plane will be rotated about this hinge into the leftward orientation over here, and after rotation this right hand side view projection will be available on the left hand side of the front view projections below the XY reference line. Similarly, when the observer is going to look at this point D from the left hand side orientation, the left hand side view projections of this point D will be obtained onto the right profile plane, and this right profile plane will in turn be rotated towards the right hand side view orientation over here. So we can conclude that the left hand side view projections will be available on right side of the front view projections below the XY reference line. So now let us evaluate the pattern of unfolding of the planes and location of the different orthographic views into the fourth angle projection method. So now here we can see into the fourth angle projection method, this is our horizontal plane, this is our vertical plane, this is the left side profile plane, this is the right profile plane. Now, as we have discussed, the front view projections will be obtained onto the vertical plane below the XY reference line. So it will stay in its position. But the top view orthographic projections will be obtained onto the horizontal plane over here. Now, this horizontal plane will be rotated in the clockwise direction or the downward direction, leading to overlapping of this horizontal plane with the vertical plane. So, we are going to obtain top view projections below the XY reference line alongside the front view projections below the XY reference line. Now, when we are looking from the right hand side orientation, the projection of this particular point from the right hand side view orientation will be obtained on the left profile plane, and this left profile plane will be moving in the leftward direction. So the right hand side view projections of the point will be obtained below the XY reference line on the left side of the front view orthographic projections over here. And finally, when the observer is going to look from the left hand side view orientation, so the left hand side view projections of the point will be available on the right profile plane. And since this right profile plane will be rotating towards the right hand side view orientation, so we are going to obtain the left hand side view orthographic projections of the point D will be obtained on the right side of the front view orthographic projections below the XY reference line. Next, we can see how the different planes they are opening up. So HP and VP, they are going to coincide. Left profile plane is moving towards the left side. Right profile plane is moving towards the right hand side. So now here we can see that front view and top view projections, they are going to overlap with each other below the XY reference line, and the right hand side view projections of the object will be obtained on the left profile plane, which will be available on left side of the front view orthographic projections below the XY reference line, and the left hand side view projections of the object will be obtained below the XY reference line on right hand side of the front view orthographic projections over here. Now let us proceed to evaluate the orthographic projections of a point D, which is lying 35 mm below the horizontal plane and 25 mm in front of the vertical plane. So here we can check. Here we have got the horizontal plane. This is the vertical plane. Now the point D lies 35 mm below the horizontal plane and 25 mm in front of the vertical plane. So as the observer is going to look at this point from the front view orientation, so we observe that this point D front view projections will be projected onto the vertical plane at a distance of 35 mm below the XY reference line. So now when the observer is going to look at this point from the top view orientation, so we observe that this point D will be projected onto the horizontal plane as plan view projection or top view projection over here, and this point D will be available at a distance of 25 mm in front of the vertical plane. So now we can check this top view projection, that is point D, and this front view projection, that is point D dash. They happen to lie in the mutually perpendicular planes. So in order to obtain 2D orthographic projections onto a single plane, we need to carry out the rotational transformation of this portion of the horizontal plane into the clockwise direction, that is into the downward direction. Now we observe that this point D has to be rotated using the center point onto the vertical plane in such a way that this distance radius should be equal to 25 mm. Now we observe that the top view projections of this point D have been obtained onto the vertical plane below the XY reference line. So here we can observe that both front view orthographic projections, that is D dash, and top view orthographic projection, that is D, they have been located below the XY reference line over here. Now here we have obtained the right profile plane over here. Now when the observer is going to look at this point D from the left hand side view orientation, so we observe that the left hand side view projection of this point D will be obtained onto the right profile plane, and once again this projection D double dash, that is the left hand side view projection of this particular point D, it is available in the mutually perpendicular plane compared to the top view and the front view projections over here. So now with respect to this vertical hinge, now we have to carry out the rotation of the right profile plane towards the right hand side view orientation. So we will be obtaining the left hand side view projection of this point D on the right hand side of the front view orthographic projections below the XY reference line. Similarly, here we have got the left profile plane available over here. Now as we look at this point from the right hand side view orientation, so we observe that this point D will be projected onto the left profile plane at this particular position over here. So we can conclude that this is the projection of the point D as the observer is going to look at this point D from the right hand side orientation. So the name of the side view projection will be right hand side view projection over here. And once again, this right hand side view projection of the point D, that is point D double dash, obtained onto the left profile plane, it is available at a mutually perpendicular location compared with top view and the front view projections over here. So now with respect to this vertical hinge, we have to carry out the rotation of the left profile plane into the leftward directional orientation over here. So this way we are going to obtain the right hand side view projection of the object or the point D on left side of the front view orthographic projections below the XY reference line. Now let us obtain the relationship between the side view orthographic projections and the front view orthographic projections over here. So as we draw these three projector lines over here, so we observe that the front view orthographic projection, that is D dash, and the side view orthographic projection, that is the right side view D double dash and left side view projection D double dash, all these three projections, they are available at a same distance, that is 35 millimeter below the horizontal plane available into the spatial arrangement shown over here. Similarly, once we draw these three projector lines over here, we are able to establish the relationship between top view orthographic point and the right side view and the left hand side view orthographic projections over here. So now we can check all of these three orthographic projections, they are available at a distance of 25 millimeter in front of the vertical plane. So this way we have been able to establish the relationship between front view projections, top view projections and the side view projections over here. So let us proceed to evaluate the two-dimensional orthographic projections of this point D, which happens to lie into the fourth quadrant. So here we have drawn the XY reference line, which is the intersection of horizontal plane and the vertical plane. We have drawn the X1 Y1 reference line corresponding to the left profile plane. So it is this hinge that we have represented into the orthographic projection view over here. Similarly, corresponding to the right profile plane, this hinge we need to obtain into the orthographic projection. So another X1 Y1 reference projection line we have obtained corresponding to the right profile plane. So here we have got the vertical plane where we are going to obtain the front view orthographic projections. the top view orthographic projection, they are obtained onto the horizontal plane. Since front view and top view orthographic projection, they are obtained into the mutually perpendicular directions. So now this horizontal plane rotation we have to carry out into the clockwise direction. So there will be overlapping of the horizontal plane and the vertical plane. So once again, this portion will also be representing the horizontal plane represented below the XY reference line. So the front view and the top view projections will be available below the XY reference line over here. Then here we have got the left profile plane where the right hand side view projections will be available. Here we have got the right profile plane where the left hand side view orthographic projections they will be available. Here we have obtained a transfer line into the left hand side view profile plane. Here again another transfer line has been obtained into the right hand side view profile plane. So these two transfer lines, they are originating from the intersection of XY reference line and X1 Y1 reference lines, and these transfer lines they are available at an inclination of 45 degree with respect to the XY reference line. Now let us obtain the front view and the top view orthographic projections of this point D. So we have already evaluated point D dash will be available onto the vertical plane at a distance of 35 millimeter below the XY reference line. So this is represented as point D dash. So here point D dash we have obtained at a distance of 35 millimeter below the XY reference line onto the vertical plane. So this is our front view orthographic projection. Whereas point D, it has been rotated into the vertical plane because this point D was obtained as a top view projection onto the horizontal plane, but due to this rotation there is an overlapping of horizontal plane with the vertical plane. So we know that this distance of point D from the vertical plane happens to be equal to 25 millimeter. So now we are able to obtain the top view projection, that is point D, obtained onto the horizontal plane, which in turn coincides with the vertical plane over here. So this point D is also available with us at a distance of 25 millimeter below the XY reference line onto the horizontal plane. So this way the front view and top view orthographic projection, they are lying below the XY reference line into the fourth angle projection method projections over here. Now let us obtain the side view projections corresponding to this point. Now we have already evaluated while we had drawn these three projection lines over here, that is this one and this one, that is the points D dash corresponding to front view, D double dash corresponding to right side view, and D double dash corresponding to left side view. They are all lying at a distance of 35 millimeter below the XY reference line. So through point D dash we have drawn a horizontal projector line onto which we are going to locate point D double dash onto the left profile plane and the right profile plane over here, so that the distance of the side view projection below the XY reference line will be equal to 35 millimeter on the left hand side as well as onto the right hand side as well. Whereas another thing, we have also validated that the distance of top view projection and the left side view projection and right hand side view projection, it is equal to 25 millimeter from the vertical plane. So now we know that point D is located at a distance of 25 millimeter from the vertical plane. So now through this point D we have drawn a horizontal projector line into the right profile plane, so that we should be able to obtain the intersection of this horizontal projector line with this transfer line. So what we are trying to do, we are trying to transfer this distance from the top view projections into the profile view projections over here. So through this intersection point of this horizontal projector line obtained through point D with this transfer line. Now we are going to obtain a vertical projector line. So what we have done through this transformation, we have been able to obtain a distance of 25 millimeter from the vertical plane into the right profile plane over here. So this way, now wherever this vertical projector line at a distance of 25 millimeter from the vertical plane and this horizontal projector line available with us at a distance of 35 millimeter from the horizontal plane. So wherever these two projector lines they are going to intersect, we are going to obtain the location of the point D double dash, which happens to present the location of side view projections into the profile plane projections over here. Similarly, in order to obtain the right hand side view projections onto the left profile plane, so once again through point D we are going to draw a horizontal projector line into the left profile plane and extend this horizontal projector line to intersect with this transfer line, so that this distance will be equal to 25 millimeter from the vertical plane. And now through this transfer line, once we obtain a vertical projector line at a distance of 25 millimeter from this vertical plane, so now wherever this vertical projector line at a distance of 25 millimeter from the vertical plane, it is going to intersect with this horizontal line which has been drawn through point D dash, which is located at a distance of 35 millimeter from the horizontal plane. So intersection of these two projector lines will provide us with the location of point D double dash into the left profile plane over here, and the name of this side view will be right hand side view projection, because observer is going to obtain this point while the observer is located on the right hand side of the point D available over here. So this way the front view orthographic projections, top view orthographic projections, both of them they have been obtained below the XY reference line. The left side orthographic projections they have been obtained onto the right profile plane. The right hand side view orthographic projections of the point they have been obtained onto the left profile plane. So this way we have completed the discussion about the construction of orthographic front view, top view, left hand side view and the right hand side view projections of the point D, which happens to lie into quadrant number 4. So this is all for today. So we are going to continue with further discussion regarding few more illustrative cases of orthographic projections of the points in the coming lecture classes. So thank you very much. Thanks a lot.